Welcome back, everybody. We are up to lesson 5 of unit 4. Once again, there are no new lesson notes, so we're going to get right into the examples. After purchase, the value of a machine depreciates exponentially. Once again, depreciates means it decreases. The table shows its value as a function of years since purchase. If a spreadsheet tool is available, consider using it to help you reason about the following questions. So what this table is telling me is that its initial value is 16 grand, and that 1 year later it has a value of this. 2 years later it has this value, so on and so forth. So number 1, find the decay factor of the value of the machine per year. Hint: to find the decay factor, divide any value by the value for the previous year. So to figure out the decay factor, I could do 13,600 divided by 16,000. I could do 11,560 divided by 13,600. Or I could do 9,826 divided by 11,560. It doesn't matter which I choose. I just pick any value and divide it by the value from the previous year. So let's go to Desmos. So if I do 13,600 divided by 16,000, I get a decay factor of 0.85. If I were to do any of these other, so let's do 11,560 divided by 13,600. Notice I also get 0.85, and you could bet that if I did this one, I would also get 0.85. The key is my decay factor per year is 0.85. All right. Number 2, write an equation to represent the value of the machine V as a function of time in years T. So number 2, I'm going to actually do that one up here. Okay. Again, I'm going to use my exponential, in this case, decay formula. So my initial value, the initial value of the machine is 16,000. My decay factor, we already said, was 0.85. And we're going to use T because it said function of time in years. So 16,000 times 0.85 to the power of T. That is my equation per year. So T, my T value in this case is number of years. Okay. Number 3. Okay. Use the equation to find the value of the machine 6 months after purchase. So I can't plug in 6 for T because plugging in 6 would mean 6 years, not 6 months. So I have to take 6 months and convert it to years. So the question is, how do I convert months to years? Well, I know that there's 12 months in a year, so I have to either multiply by 12 or divide by 12. Well, the answer in this case is I'm going to divide by 12 because 6 months divided by 12 months per year is going to give me a half of a year, right? 6 months is a half of a year. So when I plug in for number 3, I'm going to take this equation and I'm going to plug in a half for T. So 16,000 times 0.85 to the power of a half, 0.5. Okay? So let's put that in Desmos. So it's 16,000 times 0.85 to the power of a half. And we get a value of $14,751. So $14,751. and 27 cents. Okay. Number 4, find the value of the machine 9 months after purchase. So now I have to convert 9 months to years. So now I'm going to have to divide that by 12. So 9 divided by 12 is 3/4. So it's 3/4 of a year, or 0.75 years. 9 months is 3/4 of a year. So I'm going to do the same thing, except now I'm going to plug in 0.75 for t. So I'm going to replace the 0.5 here with 0.75, and I get $14,163. So $14,163.94. Okay. Number 5, write an equation to represent the value of the machine as a function of time in months, m. So the key is I have to take the number of months to figure out what value I put in for t. I have to take the number of months and divide it by 12. In number 3, I had to do 6 divided by 12. In number 4, I had to divide 9 by 12. So my equation per month is going to be 16,000 times 0.85 to the power of m over 12. Okay, so 0.85 to the power of m over 12. That gives me my equation per month. All right, I can plug in any number of months. If I divide it by 12, that will automatically convert it to years. Okay, and then last one in this section, number 6. Use that equation to find the decay factor per month. So to do that, I have to play the same game I did in the previous lesson, which means I need to take the equation and rewrite it like this. Okay, notice I have to take m over 12, and I have to break that down into 1/12 times m. So again, I take m over 12 and break that down into 1/12 times m. Once I break that down, the good thing is whatever is inside the parentheses here, that is your answer. So the decay factor per month is 0.85 to the power of 1/12. 0.85 to the power of 1/12. Okay. Next section. Between 1990 and 2010, the price of a particular product has risen about 49%. Suppose a product cost $10 in 1990 and has been raising prices by a steady percentage each year to keep up with inflation. Number 7, write an equation for the price of the product per 2 decades. Why per 2 decades? Because 1990 to 2010 is 20 years, which is 2 decades. So, what is my initial value? My initial value in 1990 was $10. Okay. What is my growth factor going to be? Well, it's going up by 49% every 2 decades. So remember from the very beginning of this unit, okay, 49% is 0.49. So my growth factor is going to be 1 plus 0.49. So my growth factor in this case is going to be 1.49 to the power of x. So that is your answer to number 7. 10 times 1.49 to the power of x. The key in this case is that x is the number of 2 decade time periods. So plugging in x equals 1 really means 2 decades. Okay. Number 8, write an expression for the price of the model or price of the product in 2010. So 2010 is 2 decades later. So I'm not going to plug in x equals 2. I'm actually going to plug in 2 divided by 2, which is 1, because 2 decades is 1 2-decade time periods. So that's going to look like 10 times 1.49 to the power of 1. That is your expression. Okay. Number 9, I'm going to do that one over here. Now we're going to write an expression for the price of the product in 2000. So 2000 is 1 decade later. So 1 decade, now I have to divide that by 2. So that's a half of a 2-decade time period. So 1 decade is a half of a 2-decade time period, which means I'm going to plug in a half for x. So that's going to be 10 times 1.49 to the power of a half. Number 10, write an equation for the price of the product d decades after 1990. Well, we figured out in numbers 8 and 9, to figure out my x value, I have to take the number of decades and divide it by 2. All right, because my x value is the number of 2-decade time periods. So number 9, that was x equals 1, because 2 divided by 2 is 1. And in number 9, that's going to be a half, because 1 divided by 2 is a half. So I have to take the number of decades, which they told us to use the variable d, and I have to divide that by 2. So that's going to look like 10 times 1.49 to the power of d over 2. 10 times 1.49 to the power of d over 2, where now d is now number of decades. D is not 2 decades anymore. So that's number 10. Number 11, what is the growth factor of the price of the product per decade? Again, I'm going to play the same game I did up here. So up here I took m over 12 and I broke that down into 1/12 times m. Down here, I'm going to take d over 2 and I'm going to break that down into a half times d. Because 1/2 times d is equal to d over 2. So my growth factor per decade is 1.49 to the power of a half. Again, once you break that down, whatever number is inside the parentheses, that's your answer. So that is it for this lesson.